From our discussion of magnetism, we've discussed Fleming's left-hand rule, Lenz's law, motors, and generators. In this video, we will consider a few questions on magnetism to strengthen our understanding of the concepts previously explained. We begin with the first question. A wire is held between the poles of a magnet carrying current in the direction shown. Draw an arrow to show the direction of the force on the wire. The direction can be found by using Fleming's left-hand rule. It is used to find the direction of a force produced when a current-carrying conductor is placed in the magnetic field. So by using the rule, if we position our left hand such that the first finger points in the direction of the magnetic field, the second finger points in the direction of the current, then our thumb is going to point downwards. So we are going to have a downward force acting on this conductor lying inside the magnetic field. The next question is, explain why a force is produced on the wire. We know the force is produced as a result of the interaction between the magnetic field produced due to the current flowing through the conductor and the magnetic field of the permanent magnet. When these two fields interact, a force is produced. The other part of the question is, what will be the effect on the force if both the directions of the currents and the magnetic fields are reversed? The simple answer is the direction of the force will not change. And the reason is, when we change only the current direction, the direction of the force will change. In the same way, if we change only the field direction, the direction of the force will equally change. Therefore, changing both the direction of the current and the direction of the field, they will cancel each other out. And as a result, the direction of the force will remain unchanged. We are still going to have a downward force. Question 2. A magnet moved towards the end of a solenoid connected to a galvanometer. During the movement, current is induced in the solenoid. The first question is, state one change that would increase the induced current. 1. When we use a stronger magnet, we are going to have more magnetic field lines, and so as it moves, more field lines will cut the coil, and so more induced currents. And also by increasing the number of turns of the solenoid, that results in a greater surface area for cutting, and so more induced current will be produced. And the third, move the magnet faster. By the field lines actively cutting the coil, we are going to have more field or more current induced. Explain why the needle of the galvanometer deflects as the magnet is inserted. The answer: magnetic field lines cut the coil, and as a result, EMF or current is induced. So the cutting of the field lines results in EMF produced. What will be the effect if the magnet is inserted slowly? There is going to be smaller deflection seen on the galvanometer, because the induced current is going to be smaller. Then the other part is, state what is observed when the magnet is withdrawn from the left end of the solenoid. When that is done, it will be like reversing the direction of the magnet. When the direction of the magnet is changed, the current direction will also change. It is going to be in the opposite direction, and as a result, the deflection on the galvanometer is also going to be in the opposite direction. And it's very important to keep this in mind. If you remember the concepts explained under Lenz's law, you should be able to easily handle a question like this. Our third and final question: part of an AC generator is shown above. First question: what is connected between the ends of A and B of the coil and the connection C and D? From our explanation of the generator, Between those 2 points, we have the slip rings and the carbon brushes. Please keep in mind, these are not split rings. Split rings are associated with a motor or the motor, but we have slip rings in the generator. So between A and B and C and D, we have slip rings and carbon brushes. Next question. Sketch a graph to show the variation with time of the current flowing through R. Because it's an AC generator, we know the induced current produced is not going to be in the same direction, and so the sketch is going to be a sinusoidal curve or a sine wave, and that is what we see depicted there, with currents on the vertical axis and time on the horizontal axis. And we have the graph starting from 0. Show on the graph the time corresponding to 1 complete rotation of the coil. 1 complete rotation of the coil is going to be 1/2 above the horizontal axis and the other half below the horizontal axis. And so 1 complete rotation is what is shown. The time taken will be from the 0 mark to the end as shown in the diagram. And the time taken for 1 complete rotation is referred to as the period. And it is indicated with a capital T. State ways in which the graph would be different if the coil spins faster. The time for 1 complete rotation will be less, or we are going to have higher frequency. And what that means is that we are going to have more rotation shown on the graph than was previously depicted. And what that means is that we are also going to have a higher amplitude, because as the coil rotates faster, we have more induced current. And so the maximum current as shown on the graph is going to have a higher peak than what was originally shown on the graph. These questions should give you a fair idea of how you are going to be tested on magnetism. Please take time to examine some other questions. You can also leave some questions in the comment below and we can address it in a later video. Thank you very much for watching. We'll see you in the next one when we continue with our discussion on electricity.